Okay, so I was trying to do a Arduino tutorial about a really simple kind of laser tag system, but I didn't have any of the parts. I didn't really feel like riding on the metro to go to a Radio Shack, which may or may not have the parts. So I ordered them from Amazon, and I tried to do the best I could with what I had. Ended up not being able to figure out any of the tutorials, which of course made me feel very bad about myself. So I ended up building this, which, as you can tell, it's sort of getting set off now because of the light. But basically what I really wanted to do was just build the first most basic circuit to see how the circuitry was working. The only photoresistor I only had a photoresistor on hand. I didn't have an IR receiver. I did order some from Amazon. In that case, maybe I'll be able to figure out the other tutorial, but I find that those tutorials are making me just feel dumb and bad about myself, and figured, hey, maybe I'm not the only one, so how about I make a video of just what I did, because I thought it was pretty simple. So this is the completed circuit, but don't worry, we're going to go through this all. I'll film myself rebuilding the whole circuit, and I will actually provide a real circuit diagram, because it's been driving me nuts that I can't find the circuit diagrams. So what this one does is I have a photoresistor here, and I know this looks messy, but I did just throw it together, and the code's even worse, so just don't be too judgmental. The way that I have it coded here is that this photoresistor, I have it coded through the Arduino, so that it says if the light input into the photoresistor is below a certain amount, I have it light this LED. There's no real reason for that. I just like having it some sort of indication that I know that it's talking the way that I want it to be talking. And then I have this buzzer here, and these all came with like the super duper beginner Arduino for Dummies kit that you can get, which is really worth it. I got mine from Adafruit. And I just wired this one up and have the Arduino talking to it. And the Arduino is telling it that if the light level is above a certain amount, then I want you to buzz. And I went ahead and had to turn off the light too. So then I got a little laser pointer out, and if I shine the laser pointer on the photoresistor, then it buzzes. That's all it does. Very simple, but sometimes it's nice to start simple. So now I'm going to go through and let's draw the circuit, and then let's go over the code, and then I'm going to rebuild this onto the breadboard. Okay, so I'm going to go ahead and draw the circuit diagram now. Sorry that I just don't know how to use this stuff well enough to make it look good, so whatever. Okay, so what I have is starting with pin 9. That looks like shit. So does that. Alright, anyway, starting with pin 9 on the Arduino board. The pin 9 is where I have it programmed to go to the LED. So what I do is I do pin 9 to the LED, and then the LED going into a 560 ohm resistor, and then that goes to ground. And this symbol for the LED right here is indicating the way that it goes. So the long lead connects to pin 9 on the Arduino, and the short lead connects to the resistor, and then the resistor goes to ground. Okay, and we have some common ground with a lot of things. So the next thing with the ground is this comes in and goes, sorry, I don't know the proper symbol, so I'm just going to write it out here. The piezo. It does not seem to matter which way you do this. I just did positive and then negative there. So the piezo is connected to ground, and then the ground, I use the ground on the Arduino board. And then the positive side is going to go to the Arduino board pin number 10. Okay, so that's our LED light, and that's the buzzer. Now for the photoresistor, a side of the photoresistor is going to ground. So we're just going to draw this down here. And this is our photoresistor. Okay, so that's our photoresistor, which is a piece of material that changes its resistance based upon how much light it is receiving. And then we actually have the photoresistor going to a 2K ohm resistor. I believe that is a black, brown, black, orange. I shall double check to make sure that that is. I never remember this code. Oh, 10K. I was way off. Yeah, of course it's 10K because that does make more sense. 10K ohm. And yeah, so that's brown, black, orange. And then that resistor is connected to the 5 plus 5 volts, and I use the plus 5 volts on the Arduino board. So there we go. There is our circuit diagram. Sorry, I bet it doesn't look good, but I couldn't find the stylus to write on this, and I don't care enough to look for it. So there's the circuit diagram. Then this is ground. Then I can show you how I built the circuit on a breadboard. Okay, so this is the code. I just tried to record a video in which I realized that it didn't save it, but fortunately I was able to figure it out again. I'm not a programmer, so if you are a programmer, then you can laugh all you want. If you aren't a programmer like me, then maybe it's useful to have somebody to go over this, and yeah. Anyway, so the Arduino code is a lot like C, apparently. The first thing I'm doing is I'm defining 3 integers. So an integer is a number, a simple number, without any decimal points. So whole numbers like 1, 2, 3, 4. 2.54 would not be an integer. So I'm defining these as integers because these are pins on the Arduino. So the first thing that I have is light pin. So that's the photoresistor, and it's going to 0. Then we have the LED pin. That one's going to pin 9. And then the piezo speaker, that's going to pin 10. Then in this part here where we put our setup code, So this just runs once, and all I'm doing is defining two outputs. So I have pin mode, which I believe is a proprietary Arduino thing. That's just letting the board know that when I'm talking about these things, I mean, I want to refer to the pins that it knows about, that have been written about before in its, the code that it already has. So it knows what I'm talking about when I say pin mode, and then I say LED pin. I could just put in here 9, but this way, if I wanted to change around what pins are, I only have to change them up here instead of trying to change every single LED pin to a number. I also think it's easier to read because now I know what I'm referring to instead of just a number. So this means pin mode 9 and then an output. This one means pin mode means I'm referring to pin 10 as I said up here, and then an output. Okay, this is the main code loop. So this is just something that's going to loop over and over and over again until we tell it to stop or shut up. I mean, in the case of this buzzer, you're going to want it to shut up, especially if you put it in backwards. Okay, so then I have integer light level. So light level, I'm defining here to be an integer. So this could be whatever I want it to be. I'm making this up right now, and I'm setting it equal to analog read, which is another function that the Arduino board knows. And this is the difference between those analog pins and the digital pins. So my photoresistor is going to analog pin A0, and I'm telling it right now that, yeah, light pin 0 is an analog read. So it's going to read the analog value there. Now the light level, I'm defining, whoa, what is this light level? The light level, I'm making a map. And I'm mapping the light value that it's reading, because it's reading numbers from 0 to 900, and I'm just mapping it from 0 to 255 because I wanted to go into a color for the LED. You could have a bigger range for the speaker pin, but I don't actually know what the speaker's range is, and I do know what the LED's range is, so there you go. If I wanted to get really fancy, I could do two different ones, but yeah, I really don't care. Then I have the light level. I'm just constraining it to make sure that it is constrained to values to 0 to 255. And this is all in one of those experimental guides from Arduino kits. So this is not original code. This part gets a little bit more original. And this is a lot for me who doesn't know how to program anything. So this is actually quite an accomplishment. So keep your Snickers to yourself. I did if the light level is less than 100, and this is just a number that I. So I have if the light level is less than 100, which is just the level I chose, so it works reasonably well with the lights off in my apartment. So if the first condition, like in regular English when you're talking, you say if X then Y. So if light level is less than 100 is in regular parentheses. Then is in these curly brackets. So if the light level is less than 100, then I want analog write. So this is where I'm getting the output, and I want it to be the analog output, the LED pin, and the light level. So these are the two variables there. Also, analog write speaker pin, and its value is 0 because I want it to not be buzzing. So this is not buzzing. This is on to the extent of what the light level it is. I mean, honestly, we could just do, we could, you don't even have to do light level. You could just have this be like, say, 200 or 255, and it would be fine too. This just makes it a little bit different if the light's shining directly on it or not. Okay, then I have another if statement. I could do else probably, but like I said, I'm not a programmer, so I'm not that good. So I just did 2 if statements, and I'm sure it looks dumb, but yeah. There you go. You gotta do the dumb stuff before you can do the smart stuff, I figure. Okay, so I just did what worked. Alright, so if the light level is less than 100, then I want the analog write to be the values of the speaker pin. So now I want the output to come from speaker pin, pin number 10, and I want the value of that output to be the light level, or I could just put in a number. And then also I want the analog write for pin 9, the LED pin, to be 0, so the light turns off. So there's the code there, and I'm sure it can be much improved upon, but there it is, and it works, and it can be tweaked around with quite a bit. Okay, so now I'm going to take this all apart, which I sort of did because I turned on the light and it was buzzing, and I'm just going to rebuild it all. So let's just take everything out. It's a pretty, I mean, I hate to say it's a simple circuit because I hate it when I'm trying to learn something and somebody's going, oh, it's so simple, it's so easy. It's like, well, yeah, it's, you know, it just, I don't know. I think that just makes people feel bad, and it would certainly make me feel bad. I mean, unless it makes you feel good to know that I don't think this stuff is simple. Okay, so following the diagram, I first want, I'm just going to grab, not color coding or anything, I'm just going to grab a random wire here, and I'm going to put it into 9, because I'm going to start with the LED. I'm just going to go in the same order that I did the diagram in. Okay, so I put that into the third row there, and I take the LED, and you see how one end is longer than the other end? So that's the positive end and the negative end. And I want the current, imagining the current to go through that way. So I want this long end to go into pin 3, or row 3 here. And then I want my 560 ohm resistor, which is a green, blue, brown, and I want that to go from the shorter end of the LED that's in row 4, and I'm just going to have it go to ground here. So there we go, that goes to ground. Okay, then you know, there's a lot of things in common with ground. Now here's the little piezo speaker. And I'm just going to stick it into what looks like 11 and 13. This thing's kind of hard to get in there. Okay, so that's into 11 and 13. I'm going to go ahead and just connect 13 to ground, which is this furthest row, because the rows are all connected. On this side, this row is all connected to each other, and this one's all connected to each other, and then on this part they're connected horizontally. So this one will just go to 11 there. So that's the piezo connected to ground. Now let's grab another wire, and I want 13, and I'm going to connect that one to 10. Okay. Now the photoresistor I'm going to put down here so the LED doesn't tip it off, and I put the photoresistor into this farthest row for the ground, and into row 30 there, and then I take my 10K ohm resistor, and I'm going to just connect that from one end of the photoresistor to this positive row here. And then we want to actually power up the board, so I'm going to take a wire from the minus sign there, and I'm going to connect it to ground on the Arduino, and you could hear it already starting to buzz because I have the program, I already loaded it in there. And then this side I'm going to connect to 5 volts. Okay, and it's kind of buzzing a little bit because the light's on. See, and that's one difference that you'll notice. Instead of it buzzing loudly, because it's not getting a whole lot of light, that's why it's sort of buzzing softly there. Okay, now just to make sure I have everything right, I'm going to go over here and I'm going to upload my program. So I have it up here. It's in that Arduino software, and just to warn you, one thing you might want to make sure is make sure the port's right, because that's the cause of a lot of errors. And then I just do Control U, and I'm going to go ahead and upload that. Okay, looks like we have some sort of problem here because the LED light's not on, but let's see if the speaker still works. No. Okay, so I went ahead and tested everything to make sure that it still works, and it does. So I guess I'll try it again and see if I can do it right this time. And for anyone out there who's all feels like being judgmental on me being too dumb to get it right the first time, why are you watching this? If you're so smart, you don't really need a tutorial, do you? I mean, I could have easily edited it out, but then I thought, well, you know, maybe there's other people that watch tutorials like this and get annoyed and feel dumb every time somebody says something's easy, and then every time you make a mistake because you assume that nobody else has made that mistake. So here you go. I'm stupid too. Okay, so starting again, I go from pin 9 on the Arduino, and I'm just going to go to 1. I want to put the long end of the LED connected to row 1, and then the short end of the LED is going to go to ground, but it's going to go through the 560 ohm resistor. And honestly, you know, this happens. I mean, this is why you always prototype stuff on a breadboard anyway. Okay, so now I'm going to stick this piezo in. Every time I stick this in, I'm afraid I'm going to break it, because it just doesn't like to go in. There we go. So every time I stick it in, I think, oh crap, what if I broke it that time? Okay, now we're just going to do pin 15. I'm going to go to ground. Okay. And then I'm going to do pin 13. That's, you know, on the board, sorry. So row 13, I'm going to go to pin number 10 on the Arduino. Should be more careful about where I'm talking. So this orange wire is going from one end of the speaker to the Arduino board. Okay, and then referring back to my diagram, I know that another common point with ground is the photoresistor, which you can see is getting rather bent up here. And then the photoresistor, I connect, so the photoresistor is going from ground on one side and then to this row 30, and then the other end of the photoresistor is going through the 10K ohm resistor, and that's going to the positive, which is going to be the 5 volts. So now I'll hook up the powers here. So I have my red wire going to 5 volts. If I was really good, I would grab a black wire or a white, but I'm not. So that's going to go to ground. Okay. We hear some buzzing like last time. But just like last time, the problem that I'm having is that the LED is not lighting up, even though I just did this off camera and it was fine. But I think I see what one big problem is right away, which is, let's just put this one here. This one goes to ground. I don't have my photoresistor plugged into my analog. There we go. That was a nice I like it when it's something stupid. Because, last bit of pride was beaten out of me years ago in grad school. So I would rather have a simple, stupid problem that I can fix than a difficult problem that I can't. Alright. So that sounds good. There we go. We turn off the lights and you can tell it's getting darker because now we can't see anything anymore. Let's see if I can. Alright, so I can get enough light, which was why I set the values as I did in the program. I already uploaded the program on here. And there we go. Let's hit our photoresistor with a laser. So this is like your pretty much most rudimentary receiver that you can get. Since I don't have any of the other parts, I was thinking maybe the next thing I'd want to do is get some more LEDs out there and maybe try to program like a health bar, like after every time it gets hit it goes down 1, which, who knows. That could be very ambitious for someone who is not as very skilled like me, but anyway. This is something that I think is simple. If you have a Arduino Experimenter's Guide, then you have all the pieces to do this, and it's kind of a different one. And I guess I'll attempt to link to the code and the circuit diagram. Anyway, I hope that helped somebody.